epsilon optimum, and then plus by 1020 times 10 to the power 6 epsilon optimum, and this is equal to 1.196 divided by 1.196. Okay, then the whole thing will be equal to, so all you need to do now is make one side equal to 0. So this is 433.1, okay, times 10 to the power 6 epsilon optimum, right? And then you have what, 486.872 times 10 to the power 6 epsilon optimum, and then the whole thing is powered by 1.234, and then you plus again, oh sorry, minus, okay, minus by 852.843 times 10 to the power 6, okay, epsilon optimum, and then you can, this is equal to power 1.196, and then the whole thing will be equal to 0. So to simplify this equation, you get 433.1, okay, plus by 486.872, okay, epsilon optimum powered by 0.234, okay, and then minus 852.843. Let me put the minus down here. Minus by 852.843 times 10 to the power 6 epsilon optimum, and this is 0.196, and the whole thing is equal to 0. So any idea how to solve this equation? Anyone? What will you use? Come on, you guys. So we are going to, let's see, we're going to solve this using, let me see. We're going to solve this. Hey, I'm trying to control something over here. Okay, so you guys is, so I need my glasses. So let's try solving this using Excel. Okay, you can also use your calculator if you want. So if you use Excel, let me launch my Excel now. Okay, so I'll make it bigger, right? Okay, so I will call. So you guys can see my Excel spreadsheet, yes? Right, we can use Excel. So this is your epsilon optimum, okay, or strain optimum, and I'm just put a value of 1.5, for example. Just put a value, okay. Then you head into, you calculate your strain or your equation, okay. From your equation, so this will be equal to 433.1. So I'm putting this equation in, okay, 433.1 plus by 486.872, right, times by this value over here, and then power by 0.234, okay. So I better put the whole thing in brackets in case something go wrong, right? And then over here you will do a minus 852.843. Sorry, there's no times 10 to the power 6 because I drop off them. And then you multiply this by epsilon optimum again, right? And then power by 0.196.
Hey, Eugene,
Yes.
I missed when it went from 1.196 to 0.196. I missed that.
Okay, hold on. Let me. I dropped the term. That's all I did.
Oh,
You get what I mean?
okay.
Okay, so let me see. Okay, oh shoot. There's something wrong over here. There's something wrong with my expression down here. So let me see. Because my fonts are really small. So let me see.
It looks like you have a D in there.
Is that it?
Yeah. Yeah.
Okay, so
And you have a D6, so you should erase that 6 as well. It should be 852.
yep, so 852. There you go. Thank you. 852, 8.8. So this is equal. Okay. So now you just use Excel. Okay. So you just from Excel. Hey, why my Excel gone missing? Okay. So from here, I'm. So there is a home. There is a go seek. Okay. So it's under data. Okay. So under data, you have this what if, right? Okay. So you click into what if, you going to go seek, okay? So the set cell is this cell that you are using, okay? And then you want this equal to 0, right? So why you want this to be equal to 0, okay? I'll show you, cancel. I'll show you. I'll make it smaller now. Hey, come on, Eugene. I even have problem controlling my mouse today. Okay, y is equal to 0 because this whole term over here, you can see my cursor, right? This term over here, you can see my finger, is equal to what? 0, right? So this whole term is equal to 0, right? So you get over here, right? You go into what if, you go into go seek, right? So B3, which is this cell over here, must be equal to 0. And this is by changing B1. And you just put okay. Okay, so the value, I think there's something wrong. Oh, sorry. So this is close to 0, right? So what we just found from this value, so it is 3 point what? So the epsilon optimum, right, what you can see over here, right? So the epsilon optimum is equal to 3.256. So we found that this value over here, right, is equal to 3.256 strain, okay? Which is a large strain, okay, for this example, which is a large strain. So that is how, so once you reach that strain magnitude, okay, I'll just show you how to find the value, okay? You don't need to use, I mean, you can use Wolfram Alpha or CatRam Alpha, but use Excel also can. Okay, so they, yes.
Where did you get the 1.5 for the strain optimum?
1.5. It's 3.256. Oh,
Before you put the formula in.
I get you. Arbitrary number.
Yes.
It's arbitrary.
Oh, okay.
Means, yeah, I can put 9 also. Okay. Okay, it's arbitrary number. So you go to what if again. Go seek. Okay, so you want it to be 0 by changing this. Okay, so you go okay, so still the same. 3.25638. Okay.
Okay, got it. Thank you.
Yeah,
So,
yes.
how many decimal, like significant figures do you want us to carry over?
Does not matter. 3.3 is fine. Okay.
Okay.
Okay. So this is what this Excel can calculate for me. Okay. So once it reaches a strain of 3.256, okay, before that AISI 1045 is going to be cheaper than dual phase steel. When you reach this strain, okay, 1045 will be cheaper than dual phase steel. So you knowing this strain, you can do a sliding scale, right? So you can start from 50 cent and then you can work up. Once you reach 3.256, okay, the cost can increase. Okay, so it's not just mechanical behavior. Okay, it's mechanical behavior of material, right? Enabling you to make decision, and more important, enable you to do what? Costing. Okay. On that note, that's all I have for today. Don't be too stressed. Okay. Enjoy life. Okay, and take it easy. I'll see you guys next week. Thank you.
Thank you.
Thank you.
Thanks.
Bye-bye. Bye.
Thank
Sorry,
you, sir.
I just had one question regarding the equation.